I'm Alex, and I work with mechanical engineers at Virginia Tech. And today, I'm going to ask 4 of them about 4 of the residents of the island of misfit toys on Rudolph the Red-Nosed Reindeer. Mark Stremler is a fluid mechanics expert. We're going to talk to him about the water gun that shoots jelly.
All right. Yeah, so I guess first, this kind of reminds me how long it's been since I've watched that show, because I'd forgotten about that.
Yeah, it's a very minor character. They just, I don't think they name him, they just show him. Or a water gun that shoots jelly.
Yeah, so I mean, a jelly gun is not a good idea to put jelly in a water gun, because I mean, the way that the water gun works is you're squeezing the trigger, and I think the jelly gun that Rudolph was talking to is one of sort of the old style ones, right? Where you squeeze the trigger, and what it does is it pushes down on a larger volume of water and shoves it out through this really little hole at the end, makes it squirt out, right? Jelly is thick, and it resists moving through that really tiny tube that is the water gun barrel. And so it's hard to squeeze it and to force it out. So it can't shoot out very easily, so you can't hit somebody with jelly from a distance very easily using a jelly gun.
Michael Bartlett is an expert in soft robotics and electronics. He makes morphing drones that can go on both land and air. So we're going to ask him about the bird that can't fly but swims.
So, robots that can perform multiple functions, especially those that can do things in environments that may vary, are really important. And I think in a lot of ways it makes it more like a real organism. You know, if you imagine a bird can fly, a bird can swim, some birds can go underwater even to catch fish. Can we make robots that do multiple functions? So one of the great exciting areas of robotics right now is making robots that can change their shape, change their function to do a diverse range of tasks, just like an animal would. If you had a swimming robot, could you make it fly? And could both of those potentially work on land as well?
Mehdi Ahmadian is an expert in railroads and trains. We're going to talk to him about the train with the caboose with square wheels. So as an expert in your field on trains, why would a train with square wheels on its caboose not be a good toy?
Well, simply because it offers a lot of resistance to the wheels being able to roll. Like when we think about a round wheel, which incidentally has been around as far back as we can ever imagine, then it was invented because it offers less resistance to rolling. So if I put enough pressure on that square wheel, then it will tend to slide across the floor. But if that wheel is lightly loaded and I'm pushing it harder, then it will be able to get over the corners and kind of go from this side to this side and kind of do this, and therefore it plops.
Kaveh Ahmed is a robotics expert, both 2-legged and 4-legged robots. So we're going to ask him about the cowboy that rides the ostrich, which seems to be some kind of robot.
So typically, you know, for example, in our robot, we work on both of quadrupedal and humanoid robots. But quadrupedal robots, compared to humanoid robots, have less degrees of freedom, easier to control. They have improved stability, better stability, let's say, compared to humanoid robots.
From what you're saying, it sounds like if the point of a robot is to carry something on its back, it sounds like the 2-legged robot wouldn't be as stable as a 4-legged robot. Is that correct?
Exactly. I think for payload transportation, for such applications, quadrupedal or dog robots, they have better stability and or dynamic stability compared to humanoid or bipedal robots.
Between a 2-legged robot and a 4-legged robot, which would be the best at carrying a load on its back?
I would say 4-legged robots. From my experience, when you deal with dog robots or humanoid robots, Dog robots or quadrupedal robots are easy to accept because they are fun, they are friendly, they look friendly, and you feel comfortable with this.
We are still talking about a toy, and kids are imaginative. So is there a way for a child to still make something good, make a way to play with this toy even if it didn't do what it was supposed to?
I would say most of the toys that I've seen kids play with, they find ways that you would never expect them to use it. So I think this toy, if it were given to a child, I think the child would be able to figure out multiple purposes for this single toy.
Let's step back. Like when we were all kids, right? We let our imagination run wild.
Yeah, so I think that would be a great kitchen accessory. Right, so if you're wanting to make a peanut butter and jelly sandwich, which would you rather do? Would you rather get out a kitchen knife and scoop the jelly, and then as you're scooping the jelly out, it falls off your knife and lands on the table before you hit your bread, right? Or would you rather take your water gun filled with jelly and squirt it, where you pull that out and you make your peanut butter and jelly sandwich as an action hero?
I can just see a kid being handed one of those trains with square wheels and going, neato. I have a toy, A, that the rest of my friends don't have, and B, whenever time I try to push this train forward and it comes to the edges, then it has to kind of bob up and down. Or when I am trying to push it, it slides on the ground or on the floor and makes all sort of noises that could be annoying to grown-ups.
If you imagine how kids take even their stuffed animals, right? They take a stuffed animal and then they could make it fly, or they could make it part of a fort, or they could make it as a member of a group of other stuffed toys that they use to do other things. So I think a child, better than most, would be able to take a toy that is not working and make it work in a way that we wouldn't have expected.